Okay, I'm Kostas, Kostas Kryptos. This is a real name, by the way, and we also named our son Kryptos. I had a debate with my previous employer where they didn't believe I would convince my wife to name my son Kryptos, but I did it. Eventually, they gave me a very generous bonus, and after that, it remained in the family as a name. I'm a co-founder, chief cryptographer at Mysten Labs now, and I used to lead the cryptography at Facebook. And even before this, I was in permission blockchains like Hyperledger and R3 Corda. I will use my laptop for this. Okay, so I will explain a few things, how we managed to go to SUI and how we actually escape all of the situation about Libra and Meta. We all started, you will see that we're 5 founders, all of them from Meta, and we all had experience from both Bitcoin and Ethereum. I was personally one of the auditors for some attacks in the past. I also broke like a lottery scheme. I also broke one of the auction schemes from A16Z. And in general, I'm the guy who is breaking stuff, especially on the smart contract when there is cryptography. And then the slides here will be technical again, but we will go through the consensus scheme because it's completely different from what you've seen both in the Bitcoin and the Ethereum. And then we will explain the new language that we have, the SUI move language, and how it compares with at least solidity in some sense. And at the very end, we're going to see what do we do in cryptography and why we tried as a new L1 to learn from the problems of the past, like blockchains, and we added directly some very interesting cryptographic tools on our framework. Finally, we have a slide about tokenomics, and at the very end, some applications for which I know for sure a few of you might see them as a startup opportunity. Nobody has implemented them fully, but we can see from partners some interest already. So very quickly, how did we manage to go to SUI? All of us, the 5 of us, were used to be like the leaders of the Facebook team. And as many of you know, Facebook had this Libra blockchain where they tried to have both like a basket of coins, like an ETF on fiat currencies, from dollars, euros, yen, Japanese yen, and all of this stuff. And eventually there was also a blockchain built in a completely new language that was developed inside Facebook. It started there. And actually started there from our CTO now at Mysten Labs. The CEO of Mysten Labs was the director of all the blockchain R&D at Facebook, and he was previously actually the guy who won the ACM award on secure systems for LLVM. So if you're running also an iPhone device, you're also running his code. And then we led the consensus and privacy research, and as you can imagine, after the collapse of Libra, we had so much knowledge around the blockchains for something that didn't actually fly. And at the same time, we are in an organization that some of the latest research activities couldn't be applied on the network. It also didn't manage to go out. And then we had all of the baseline of creating something completely new, and from the learnings that we had from Ethereum. By the way, many of us are already advisors on like Bitcoin or Ethereum firms. ChainSpace was a company bought by Facebook, and this is how Libra was created. And as you can see, Celos, Omeguera as well, Celestia, and some others. So at least 10 blockchains in our past, and this is how we ended up on SUI. Something that we also did is, as you can see, the second one here, the narwhal and task, is one of the most modern consensus algorithms you will find in the space. We had the Bitcoin, which is just mining. We had Ethereum, which is using like a different consensus algorithm. And this one is considered the fastest in the space at the moment. And we have a wallet, of course. And by the way, I was also responsible of the solvency proofs algorithm. Imagine the FTX situation in the past MTGOX. We were featured also in the news that if these algorithms were actually implemented by these exchanges, they wouldn't have been in this particular situation of bankruptcy. I'm leading the standardization on this one. So we have a few things like many best paper awards. There is so much R&D in the company that I believe on the left bottom corner, it's probably the first startup in the world that we had, for example, 4 papers on financial crypto, which is one of the biggest conferences in the space. So our goals, especially if you see it, many of you are now Ethereum developers, if you see it from the angle of Ethereum, are usually having like higher throughput, but also lower latency. You know all of the blocks and how many seconds does it take in many blockchains to produce a block. And we're focusing on both DeFi and especially the gaming industry. Imagine if you are playing a high frequency game, even chess, and you have to actually make a move, a blitz chess every less than a second sometimes. This is impossible to happen in other blockchains. And we found some ways, and you will see how, to avoid all of these latency issues on creating new blocks by having a fast path, avoiding the full consensus, and at the same time proving that is correct. So what is the main ingredient here? Right? How did we manage to avoid consensus? So there are many cases where in theory you can provide parallelism, because in practice if I'm sending something to you, and someone else is sending something to another person, why do we need this? Why do we need to order these transactions if they are completely dependent? There is no reason, right? However, if you can see most of the actually previous construction, they create a block for any transaction, even for independent transactions. And this doesn't make sense. And that's why, in theory, you can parallelize stuff, assuming you can understand if there is some conflict. And we managed to do it by converting the assets into different types. And right after, I have a move specification, very easy, how to understand and how the protocol understands, even without the user knowing it, to avoid all of the conflicts. So avoiding full consensus and parallelization is actually the thing why Sui is now here and is competing with all of the other blockchains. The whole trick is when we are submitting a transaction, we can get a different finality, which is super fast, if we know 100% that this transaction will not collide. I have another slide. I will move on a bit faster here. So it's this one. Imagine you want to touch in a particular contract some ID, some object ID, and I want to send it to somewhere else. And there is another transaction that is running in a different core in the system, and that's the parallelization even inside the node that is running the blockchain. We know 100% that because they have different IDs and they are owned from different people, we know that these assets can never conflict between them. And the most interesting part is balances. How do you have a balance now on Ethereum? So on Ethereum, you usually have this address on the top, and you have a balance, and you have a nonce. And all of this create your Ethereum account. And then you have the Ethereum contracts, right? The Ethereum contracts also have an address. They also have the functions there where we actually have all of the logic. But many times, especially on ERC20s and some other contracts, we have an ownership map. What is the map, right? Conceptually, in Ethereum, we believe that when we see this hash map of having a user ID and an NFT, that this user ID, this account, owns this NFT. But it's never reflected in the language, the essence of ownership. This is just conceptually, we believe this by convention. So what we changed is actually we made the account completely stateless. There is only address, and this address is owning assets. And now, imagine the assets left from the ownership map. They're completely dependent now. They belong to their own place, and the contract can only actually have only the functions. This is a shared object where everyone can access. They can run functions. It doesn't necessarily have state, because it can have a state, but your assets are not in the state. And now let's see what's happening if you are running an Ethereum transaction. I want to send some money from my address, and also I want to run 10 transactions from my address. Do you understand what's the problem here on congestion? Can someone explain why on Ethereum you have to order transactions even if by yourself you are the only person who is submitting transactions on the network? Imagine this as a database and tables in a database. Can someone explain why Ethereum orders transactions? It's super easy, right? This is a table in a database, imagine it, and I want to extract some balance from my address, and then I have another transaction that also wants to extract some balance from my address. If we don't order them, we don't know exactly who is going first to the table, and then obviously you need to have a full consensus over all of your transactions personally. But it's not only the problem of personal transactions. Imagine that someone is also sending you your balance, and at the same time you want to extract value from your balance to send it to someone else. Again, you are touching the same table. And this is why the account model of Ethereum cannot easily be parallelized. It's impossible. And there is another thing, it's the Ethereum contract stuff, right? On the Ethereum contract stuff, we usually have the ownership map there, literally a huge hash map of who owns what, which means that if we have ERC20, every single time any person is touching this ERC20 protocol, they are locking the same table, which means that there has to be an order between all of the objects in this hash map, which means that all the transactions touching this particular contract have to be ordered. And what's the difference with what we're doing here? The difference is we try to go UTXO. We try to combine Bitcoin with Ethereum. And as you know, in Bitcoin, even your balance is not a real number that goes up and down. It's not like a numeric value. It's an NFT in practice, but it's not NFT. It's like an asset which is reflected as an object. And now, if I want to send from my account an object to someone else, the other objects that I own are not affected, which means I can parallelize submission of assets. And if someone is sending another asset to me, it's not affecting all of the children, all of the other objects that I have, which means that I can keep receiving stuff, and at the same time, I'm also sending stuff. Which means we avoid congestion completely, and even in the contract can only be functions. This is stateless, right? Everyone can touch the contract. The assets, imagine them as children under your address, so we can have full parallelization. And this was the full trick to actually achieve all of the TPS and latency. Something else that is also important is because we understand now which assets require to go through this no full consensus, you just need signatures from validators. What a user is doing is actually sending the message to 2F+1 validators. 2F+1 is usually to achieve the 67% of voting power. And if you get signatures over it, you know that this transaction will be finalized, which means that if we go to Starbucks now, we don't need the validators and I just want to pay them by giving them a gas object, like something which is like $5. We don't need to wait for a full consensus. If we get to F+1 signatures, we show this to Starbucks, and Starbucks is 100% that it has finality, and this one will eventually go to a block. Now they can serve you like the coffee. And by having this example, we apply the same thing on social networks, on games, on everything that, yeah. There is no replace? You still have to pay fee. After finality? Well, if there is finality, it's final, right? I mean, the question was, there is no resume by fee, right?
No, replace by fee. In Ethereum, you can send with the same nonce the transaction many times. This is why Starbucks cannot know if you just have a signature.
This one means that it was not final and you want to overrun something, right, to front run. In this particular case, if you get the finality evidence, the new transaction will not get signatures from the validators, right? Because already 67% voted. If they see the same version of the object coming again, or the same like thing that you want to spend, they will not sign it. The best you can have is the other 33% signing it. But this is not enough for the second one to front run it. And based on all of this concept, we have a completely different system, right? I mean, even your way of creating smart contracts now is now different with SWI. And there is another benefit that we see, and this is because we switch the language from Solidity that you are familiar with to Move. And in Move, there is strict types. It's the same thing as if you are a Java or Rust developer. You can actually have object types like a tiger, a cat, a dog. You have things, and you know exactly what you are sending from one contract to the other. And this allows for contract composability by far better than Ethereum, where everything you're trying to compress to U100 to U256 to a number, right? Because on Ethereum we assume that whenever I see something that defined by the smart contract as this is a user ID, we have to accept it. The contract developer said that this is a user ID. But here you literally created a new object. And this new object is under a module, which means that a new developer can now create a new smart contract that he works on my assets that were created in another smart contract. And the whole VM will never be confused because now there are real structures which cannot be confused with each other. And in this particular case, we're 100% sure if we see a card title, I pay some fee which is a coin type, it's not something else, I will receive a registration. And then you cannot miss this even if there is another contract that says, okay, I want to read car registration from someone else's smart contract. And now it's super easy to do composability. And you're creating a completely different way of writing smart contracts, similarly to what we did on conventional languages. Because in Ethereum, we changed our mindset originally, right? We had to compress stuff because we know transactions are expensive, we have to pay fees. But if you manage to have parallel transactions now, you can actually reduce the fee up to the minimum, and now you can have bigger structures that you can actually use them for better programmability. If you understand this, I believe this is the main difference between conventional blockchains and SUI. And I will go to something else which is also super important, cryptography API. Previously, we had the speaker mentioning for some precompiles, right? The EC recover thing, which was related to ECDSA on Ethereum. The main benefit with SUI is it's so agile that even at the genesis, we can allow so many cryptographic primitives without expecting from third parties to bring them to the network. So we have cross-chain signature verification. There is a reason for this. SUI is coming after Ethereum and after Bitcoin and after all of this. So we learn from all of those. Solana is using ETDSA. Ethereum is using ECDSA K1. Someone else is using another algorithm, Snore. So what we said, okay, we want a new blockchain, and now we want this to be compatible with all of the other wallets, existing wallets. Whatever you have, you can use it. And then we allow now an Ethereum signature to be verified inside the SUI contract. On Genesis, we don't need a third party to actually do that, which means that even for Axelar, because we are working as well on the bridging stuff, it's very easy for them to create a bridge because the oracles, if they sign Ethereum signature, that's fine. It's already supported by SUI. And even on the wallet side, right? On the wallet side, you can now pick the algorithms. You can say, oh, this is on the agility part. I want to use my iPhone to sign a transaction. And then we said, okay, what algorithm is Apple using for their enclaves, right? If you get your phone, inside your phone, I mean, it's an iPhone or a high-end device on Android, you do have a secure enclave. Not even you as an owner can have access to the private key. Now we allow in SUI to sign with your phone. You can never extract your private key here, right? Maybe, however, you say, okay, what if I lose my phone? And then we said, okay, let's allow multi-sig internally to SUI from day one. And now you can have a 3 out of 5, and you say, okay, or 1 out of 2, I use my mnemonic, or I use my iPhone and mnemonic. Whenever I don't have the mnemonic, I use my iPhone very quickly. And if I lose my iPhone, I just go and get the mnemonic from the vault, wherever I have it, and then I can rotate the key to something else. I can send the asset somewhere else. And you can use now the iPhone as a 2FA. You might say 2 out of 3. Whenever I use the mnemonic, I also want a notification here. And after this, the transaction is considered valid. So we changed completely all of the initial requirements from wallets to come from different other environments into SUI. And there is another one around wallet specifications. And this is very important because it will change your perception around pre-approvals of transactions. What is the major problem on gaming? On gaming, if I want to play chess, and every chess move has to be registered on chain, and you use a wallet, you will see the following. I move a piece from d4 to d6, something, a pawn, and then the wallet pops up. Sign this transaction because you have to give me a signature for this. And then you make another move in another second, and again a pop-up. This is like destroying all of the UX we are aware of, right? But what's happening now? We have SUI assets which are not belonging even to the contract, which means we generalized the way ownership works. And then you might say on your wallet, okay, here's the thing. I'm playing this chess game. This is the ID of the object that I'm playing. I'm giving you also an ID of an object to spend, like up to $2. I have an object of $2. Don't bother me for $2. For the next 10 minutes, just blindly, like silently sign on the background. And this can actually be in the rule of like the wallet even of chain. So the wallets will start allow listing some smart contracts, and then all of the UX will become by far more easy compared to all of the other blockchains. And this is because we have this, which you can say on the wallet, for this object, don't bother me anymore. And even your balance, right? Not the whole balance of your object is now available for a malicious application to drain it. You just create a new object with $2 instead of creating a burner wallet, a new address, and then the worst that can happen is you lose your $2. So obviously there are new benefits here, and something else is we literally have the fast crypto library. If you go to this fast crypto bench, I don't believe there are many cryptographic libraries out there with these benchmarks. Even if you are not using SWI, use our fast crypto library because, in some particular cases, we have record speed. Let me very quickly see if I can open some of them. So, okay. So if you go to our benchmarks on fast crypto, you will see, okay, I want to do BLS verification for some zero knowledge proof scheme, which is Growth 16. What is the performance here, right? I want to know in Rust. We pre-compile things in Rust and then we convert them in Move. And then I can give you some examples where some people don't know it. Which one is faster, EDDSA or ECDSA on verification? Solana is using EDDSA. Ethereum is using ECDSA. Do you know? Although EDDSA is considered the new version of ECDSA, the Bitcoin community optimized ECDSA at the level of assembly, where if we go to verification, we will see, for example, if we want to verify an EDDSA signature, it takes around 56 microseconds, right? And then you can come here and see everything that we have done for you. Then if I go to ECDSA K1, it's half of it, right? 35.4. And this is because we use precompiles from Bitcoin to Rust and then to Move. And then we managed to get all of the fastest cryptography into our blockchain. And someone will be surprised, okay, what about iPhone? iPhone is using a different curve that was not in the Bitcoin community. Oh my gosh, too expensive. Why is that? Do you know why is that? The R1, Unfortunately, the structure of the elliptic curve, so the answer is we cannot optimize it as we could optimize the K1 curve from Koblitz that was used in Bitcoin. There was a reason that they used this, apart from the fact that R1 is from NIST, right? And not every country believes that NSA and NIST are putting the non-broken parameters on the elliptic curves. But there is another thing I will add on top of you. It's not that you cannot optimize it a lot. There was no requirement before the Bitcoin to optimize them at the lowest limit possible. Because on Bitcoin and Ethereum, you pay a lot of stuff if this is double the speed. I totally believe that the blockchain community actually completely changed the mindset of cryptography. We made so many primitives much faster just because there was the economic incentive which was direct from the general population, not only from some countries or some agencies or some big companies. And then if you go to this link, you will find all of the stuff. Something else that you need to know is we even found, based on all of these benchmarks, we even found that, for example, base 64 is malleable. Some people will believe, whenever I have the word hello and I get the base 64 of hello, I will always get the same thing. Did you try it? In theory, the base 64 should be 1-to-1, but most of the libraries out there violate this. And it is possible on the decoder to actually omit the padding bits at the very end. You remember all of the base 64 are finishing with some equal symbols, some pluses, some special symbols that we see. They don't read them. So if you go and change it, they will do the correction, which means that if you are using a database and you are saying, my primary key is a base 64 string, for this user ID, you might find the same user ID multiple times there, violating completely everything. We couldn't do this stuff if we didn't have all of these benchmarks. That's why I believe you should use fast crypto even if you are not on SWI. So I will go to something else, which is like tokenomics. It's very important when you are moving to a new blockchain that it's clear how I earn money, how validators earn money, how I stake, how I lock my funds and say, like in real democracy, I want to actually have $1 million and I delegate my voting power to some validator that they will vote on behalf of me for the new transactions. This is a delegated proof of stake. When you hear that, is everyone can lock assets or can give their voting power to some validators to represent them. We did this, and obviously the stake rewards for the validators are transaction fees, plus some stake like fee that they want to get from like the users. So if I stake 1 million, maybe the validator will say, okay, I will do the voting for you, but you have to give me from your profit out of this like 2-3%. So we created a very good environment from day one, and even for the wallet to support staking. So imagine a MetaMask for Sui that all of the wallets in the world can also allow you to invest your money. The other thing is, we even gave the option to the users to get money back if they delete their objects. You have some storage, right? I mean, you cannot create unlimited NFTs and put data there, because all of the validators of the future have to carry the data of the past. But you are only paying usually per block the validators. This is very unfair for the new validators, right? Even on Ethereum. Why should I get actually, should I carry all of the state of the past just for being paid on the new blocks that are created? So we give the incentives now. If you delete your object, you are getting something, some Sui back in return. And this will also change the mentality of some applications that they feel we will forever store stuff. No, you have an incentive to also delete stuff from the chain. And then we don't keep it on the state machine, and you don't actually, you have a hash which doesn't have a particular data under this. And this allows new validators to come easier into the system, because first, all of the money for future deletion are going into a particular storage fund, and the new validators are also earning from storing stuff of the past. And we do the same for gas. So for the gas price, we have the reference gas price. We know that gas is a very complex topic on Ethereum, even in other blockchains. So there will be a reference gas with high probability, whatever is the network like TPS operations, you will pay what you expected to pay. And even if this is not like correct, every epoch, they will actually vote for what will be the new gas price. And there is always a tallying rule as well. Maybe sometimes we want to punish people who are not following the rules. Having said that, there are 3 cool applications you can do with Sui that is usually more expensive to happen in other blockchains. The first one is Elon Musk. Twitter on Sui. What is a tweet? A tweet is an NFT, right? I'm not drawing something now. I'm sending a text. And this text has some state, and it might have also a reference to another text. So you can easily, with our system, I don't know if it's clear here, but it's very easy to our system. No. To actually have and implement any NFT as being an asset owned by the others, which means we can have all of the parallelization we talked before. And you can create a Twitter today. We even have a chat. If you go to this one, you will see it's about 70, 80 lines. You can have a Twitter on Sui today. The main benefit is you can also have encryption public keys and encrypted posts. And in practice, what will happen is you are creating a WhatsApp now. You are creating a signal. What is a public key? You just have an address, and the address owns a public key, which means that I can search, oh, do you have a public key? So I can send you something on the blockchain encrypted. And now you can very easily, by having objects under addresses and not inside contracts, to reuse this public key for between Signal and WhatsApp, which was previously more complex. You had to have 2 public keys for both applications. And the benefit with Twitter on chain is then you can have, okay, this is the database, right? And then we can have all of the different UX of Twitter and say, okay, we all read from the same database, this is Sui. But kids to Twitter will only load stuff which is filtered already by this company that is available only for kids. Someone will use for edit, someone will use a generic Twitter, someone will use for something completely different. So even if they all point to the same database, which is like the Sui platform, the public bulletin board, they can actually decide what to do for filtering, because this is the major question. Can you put whatever you want on chain? Now Facebook and YouTube sometimes are censoring some data, right? Yes, you can do, but you can do at the application layer. The other cool application is Satoshi Flip. For many that you don't know, randomness was the first application of Bitcoin, sometimes 51% of the total circulation. We have implemented this on Sui, and it's also like 50, 80 lines of code, and it's super easy to have a lottery on SWI. And the final one, we have zero knowledge proofs, right? And there is now a government, there is like a big company operated by the government who is also exploring, oh, let's do age proofs on SWI. Prove that you are over 21 without revealing your age. And this wouldn't be possible on Genesis. This is my last slide. If we didn't have all of the crypto API as part of SWI on day one. That's all from my side. I'm done. Great.